Hello, Professor C is back at it again with another chem problem. Sorry, got my stuff. Ooh, I got a wrong problem. Okay, we're doing question 18, and I'm here with Gus. And before I begin, I want to shout out to my roommate Mason. Mason, big help. I ran out of markers, so I'm borrowing some of his. Thank you, Mason, my hero. Anyway, sorry, this is my third time trying this because it's like a vacuum in the hallway. I think it's gone now. You probably can hear it. Ignore if it comes back. I'll try to talk over it. Anyway, let's start question 18. If you need 400 milliliters of hydrogen gas to conduct experiment at 20.5 degrees Celsius and 748 torr, how many grams of zinc should be reacted with excess hydrochloric acid to obtain this much gas? Whoa, that's a lot, Gus. So, let's read the first part of the equation again. If you need 400 milliliters of hydrogen gas to conduct the experiment at 20.5 degrees Celsius and 748 torr, let's ignore the zinc part for now. So, if you notice, Gus, we have basically every single unit for our gas equation. I believe it's, this equation, P times V equals N times R times T. If you notice, we have every single variable. We have pressure, which is 748 torr. We have volume, which is 400 milliliters. We have T, which is 20.5 degrees Celsius. And we have R, the universal gas constant. So Gus, sorry, some people walk by. So Gus, if you notice, the only thing we don't have is in moles. So let's go ahead and find that, Gus. Let's go ahead and find that, Gus. So our first step of this problem, we're going to be looking for how much hydrogen gas we need. Okay, Gus? Or how many moles of hydrogen gas we need. So we can rearrange this equation as wait a minute. Wait a second. Okay, sorry. Wait. Just give me one moment. Okay, sorry. I thought I did my work wrong for a second. I was making sure I did it right. Anyway, to find amount of moles of hydrogen gas, we can rearrange this equation to N equals P times V divided by R dash T. If you're wondering how we did that, we divided both sides by RT to get N alone. That cancels out, leaving us with just that. Leaving us with just N equals PV divided by RT. Alright? And let's go ahead and write our units out. So our pressure was, I'm sorry by the way, I know there's a reflection right there. I can't close the window. So I'm going to try to write it lower. So P is equal to 748 torr. V is equal to 400 milliliters. We don't know our N, that's what we're looking for. R is the universal gas constant of 0.0821 liters ATM divided by moles times Kelvin. And our temperature is 20.5 degrees Celsius. Well, you might just be inclined, Gus. You might just be inclined, Gus. Well, why don't we just go ahead and plug all these numbers into the formula? Well, the problem with that, Gus, is we need all our units to cancel out and only be left with moles left. Moles left. And clearly, as you can see, Gus, we need to convert degrees Celsius to Kelvin to cancel out that. We need to convert this to liters to cancel out that liters. We need to convert torr to ATM to cancel out this ATM. And then all that is going to be left from the universal gas constant is moles. And that's going to give us the amount of moles of hydrogen gas. So converting 400 milliliters is the easy one. 400 milliliters is 0.400 liters. 748 torr. Let me get a calculator for this. 748 to convert 748 torr, we need to use the equation 1 ATM is equal to 760 torr. So we divide 748 torr by 760 to get how many ATM it is, which is this number, 0.9842 ATM. And our last number we need to convert is Celsius to Kelvin. So 20.5 degrees plus 273 is 293.5 Kelvin. And now we can plug all our numbers into this equation. So let's get through that. Yeah. So 0.9842 ATM times 0.4000 liters divided by 293 Kelvin, 0.5 Kelvin, excuse me, times 0.0821 liters ATM. And since we're dividing by this, the moles in Kelvin go on top. Or get multiplied on top. Yep. And let's look at our variables. Kelvin cancels out with right here. ATM cancels out with ATM. Liters cancels out with liters. And look at that. All left is moles. So we're gonna, give me a second while I plug this into my calculator. Sure. Yep. And this gives us N is equal to 0.01634 mole of hydrogen gas. And if you're wondering how I knew hydrogen gas was H2, in its natural state, hydrogen is always going to be H2 as a gas. Anyway, so we've solved the first part of the equation. What was the second part, Gus? The second part is how many grams of zinc should be reacted with excess HCl to obtain this much gas. So if you recall, or you might not recall, or I guess, yeah. So next step is just a stoichiometry problem, basically. What am I doing? What about this for a reason this time? There we go. Sorry. So for the chemical equation of zinc plus hydrochloric acid, I'm not going to write the states for this, just because it doesn't matter. That's fine. Or, yeah, I'll write the states. So I feel like I don't want to get any points deducted, Gus. So zinc's going to be a solid probably. Hydrochloric acid will be aqueous. And this will equal to ZnCl2 plus hydrochloric acid gas. So I moved out of the way, kind of did the same thing. So zinc plus hydrochloric acid will turn into zinc chloride plus hydrogen gas. And the reason, hold on. I haven't balanced it yet. I'll balance it in a second. So the reason why the reason why there's two chlorides and zinc zinc chloride is because zinc usually has a positive +2 as an ion, and chloride has a, I'm gonna write it out. Zinc is as an ion of +2, that's oxygen, sorry, +2, and Cl is usually negative. So in ionic bonds, they want to have a neutral bond, so like they want to cancel out. So to cancel out the +2 charge, there'll be 2 chloride needed. So ZnCl2. Yeah, sorry for naming it. And we already know hydrogen in its natural state becoming gas will be hydrogen gas. And let's go ahead and balance this out. And now it's balanced. Oh, and by the way, might as well say it. The reason why HCO is aqueous is because it's in water. That's the only reason why. Anyway, let's go move on. So, if we recall, the question is, how many grams of zinc is needed to react with HCO to obtain this amount of hydrogen gas? So basically, we need to know how much moles of zinc is needed for the same amount of moles, or how many moles of zinc is needed for that many moles of hydrogen gas, and then we need to convert that many moles of zinc to hydrogen gas, or that many moles of zinc to grams. Sorry. Well, I think, so we look at the balanced chemical equation. Per 1 mole of hydrogen gas, there is 1 mole of zinc. So the amount of moles of zinc, Zn moles, will be equal to the exact same amount of moles of hydrogen gas. So amount of moles of zinc is equal to 0.01634 moles Zn. Because 1 mole of zinc is there will be 1 mole of zinc per 1 mole of hydrogen gas. So it's the same amount of moles. However, does not mean the mass is the same. Because hydrogen gas and zinc have way different masses. So to convert moles of zinc to grams, we need to multiply it by its molar mass. So I'll write that down in a dimensional conversion, whatever. So per 1 mole of zinc, there is 65.38 grams of zinc. Sorry, I didn't really have that neat. I'll repeat it in case you can't really read it that well. Per 1 mole of zinc, there's 65.38 grams of zinc. So we multiply 0.0163 moles times 65.38. And this will give us our final answer. The amount of moles of zinc. And this gives us 1.068 grams of zinc. So if you're still a bit confused by this, Gus, about what does this mean, recall the original question again was how many grams of zinc is needed to obtain 400 milliliters of hydrogen gas? That's basically what the question was asking. So if we convert, if this many grams of zinc were to react with hydrochloric acid, this amount of moles of hydrogen gas would be formed. And then at a pressure at 748 torr, this amount of moles would create 400 milliliters of gas. That's the best way I can describe it. Thank you. Have a great day.